The values of two or more independent variables we use to explain, describe or predict the value of another dependent variable. So in this interdependence method, they are used to understand the structural makeup and underlying patterns within a data set. When we have the smaller data, it will be easier for us to explore the data, visualize the data, and it will make analysis more easier and faster, especially for machine learning. Hello everyone, I am Purnima, faculty in the Department of Commerce and Management, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. I welcome you all to this session. In the session 8 of Unit 5, we will have a discussion on what are the dependence methods, what are the independence methods, and let us see what the session holds for us. Now, what do we mean by dependence method? So, dependent methods are used when one or some of the variables are dependent on others. So, when the variables are dependent on others, we use the dependence methods. Dependence looks at cause and effect. In other words, can the values of two or more independent variables be used to explain, describe or predict the value of another dependent variable? So, in this dependent method, we will be making use of two or more variables which are dependent on the others. So, here the dependence looks at the cause and effect. So, what is the cause for the variable and what is the effect of that variable? So, here the values of two or more independent variables be used to explain, describe or predict the value of another dependent variable. To give a simple example, the dependent variable of weight might be predicted by independent variables such as height and age. Suppose you have to predict the weight of a person. Now, the weight of a person, it depends on the age of the person and also the height of the person. So, these two are the independent variables based on which we can predict the weight of the person. Now, in machine learning, dependence techniques are used to build predictive models. So, this kind of a dependence technique, this kind of a dependence method, it is mainly used in machine learning where we are made to build models. So, when we are building models, we make use of this dependence methods. The analyst enters input data into the model, specifying which variables are independent and which ones are dependent. In other words, which variables they want the model to predict and which variables they want the model to use to make those predictions. Now, this kind of a dependence method, it is used for making models. Now, when you are making the model, the input analyst, he will put all the variables which are dependent and all the variables which are interdependent. So, in this way, he will be able, the model will be able to be predicted in the machine learning. Then, in interdependence method. So, in this interdependence method, they are used to understand the structural makeup and underlying patterns within a data set. So, in this case, no variables are dependent on others. So, you are not looking for casual relationships. Now, in this interdependence method, the variables are independent. They are not dependent on any other factors. So, rather, interdependence methods seek to give meaning to a set of variables or group them together in meaningful ways. Now, in this interdependence method, so whatever the variables are given, they will be giving a meaning to the variables and also it will be useful for or helpful for us to group them together. One is about the effect of certain variables on others, while the other is all about the structure of the data set. So, what is the structure of the data set and what is the effect of the certain variables? So, all this we will be able to know with the help of this interdependence method. With that in mind, let us consider some useful multivariate analysis techniques. So, there are certain multivariate analysis techniques. In this, the first one is the multiple linear regression. Second one is multiple logistic regression. Third one is the multivariate analysis of variance, also called as the MANOVA. Next, we have the factor analysis, and lastly, we have the cluster analysis. Now, let us see what is multiple linear regression. So, multiple linear regression is a dependence method which looks at the relationship between one dependent variable and two or more independent variables. So, multiple linear regression is a dependence method which looks at the relationship between one dependent variable and two or more independent variable. So, it looks at the relationship between one dependent variable and two or more independent variables. A multiple regression model will tell you the extent to which each independent variable has a linear relationship with the dependent variable. So, it will just tell us how the independent variable is having a relationship with the dependent variable. This is useful as it helps you to understand which factors are likely to influence a certain outcome, allowing you to estimate future outcomes. So, this kind of a multiple linear regression, it will help us to understand which factors are likely to influence a certain outcome. So, what are those factors which influence the result, and with the help of which we will be able to estimate the future outcomes. Then, next one is the principal component analysis. A principal component analysis is a dimensional reduction method that is often used to reduce the dimensionality of large data sets by transforming a large set of variables into smaller ones that still contain most of the information in the large set. So, principal component analysis is a dimensionality reduction method. So, this is used to reduce the dimension of the data. So, when you are having a large set of variables, you transform that into a smaller one so that the information is there. So, that still contains most of the information in the larger set. Then, principal component analysis. Reducing the number of variables of a data set naturally comes at the expense of accuracy. But the trick in dimensionality reduction is to trade a little accuracy for simplicity. So, when you are having large sets of data and when you are trying to reduce the data given, it comes with that you will be just having to compromise with the accuracy of the data. We have to trade accuracy for simplicity. So, in order to simplify the things, we have to lose a bit of accuracy here, because smaller data sets are easy to explore and visualize and make analyzing data much easier and faster for machine learning algorithms without extraneous variables to process. So, when we have the smaller data, it will be easier for us to explore the data, visualize the data, and it will make analysis more easier and faster, especially for machine learning. To sum up, the idea of PCA is simple: reduce the number of variables of a data set while preserving as much as information as possible. So, you try to reduce the number of variables in the data given set and try to see that there is lot of information preserved in that particular data set. Then, next one is, what is factor analysis? Factor analysis is a way to condense the data in many variables into just a few variables. For this reason, it is also called as dimension reduction. So, in this factor analysis, we are reducing the number of variables into a few variables, and that is why we also call it as the dimension reduction. You can reduce the dimensions of your data into one or more super variables. The most common technique is known as the principal component analysis. So next one is the factor analysis. So the factor analysis uses the correlation structure amongst observed variables to model a smaller number of unobserved latent variable known as the factors. So it uses the correlation structure amongst observed variables to model a smaller number of unobserved latent variables known as the factors. Researchers use the statistical method when subject area knowledge suggests that latent factors cause observable variables to covary. Use factor analysis to identify the hidden variables. So, this factor analysis, it will have an analysis of the observed variables and it will be able to predict a model a small number of unobserved latent variables known as the factors. That is, it will try to show us what are the hidden variables. So, with the help of the factor analysis, we will be able to bring out the hidden variables. Then, analysts often refer to observed variables as indicators because they literally indicate information about the factor. Factor analysis treats these indicators as linear combinations of the factors in the analysis plus an error. The procedure assesses how much of the variance each factor explains within the indicators. The idea is that the latent factors create commonalities in some of the observed variables. So, with the help of the factor analysis, we will be able to it will indicate the information about the factor. So, it treats those indicators as linear combination of the factors in the analysis plus an error, and within the idea is that the latent factors creates commonalities in some of the observed variables. Then, for example, socio-economic status is a factor you cannot measure directly. Suppose you have to measure the socio-economic status of a given set of people. You cannot measure it directly. However, you can assess the occupation, income and education levels. But with the help of the occupation, income and the education levels, we will be able to predict the socio-economic status of the people. These variables all relate to the socio-economic status. People with a particular socio-economic status tend to have similar values for the observed variables. So, if the factor SES has a strong relationship with these indicators, then it accounts for a large portion of variance in the indicators. So, the socio-economic status, it can be assessed only when we have information relating to the occupation, income and the education level of the population. So, people with a particular SES status tend to have similar values for observed variables. So, for these are all the variables for which they will have the similar values. Now, if the factor has a strong relationship with these indicators, then it accounts for a large portion of the variance in the indicators. So, all the numbers which you have assigned for occupation, income and educational status, they all account for a large portion of the variance in the indicators. That is, so there is a strong relationship between the socio-economic status of the people with their occupation, with their income level and with the education level. Then, next one is the discriminant analysis. So, it is a vital statistical tool that is used by researchers worldwide. Machine learning, pattern recognition and statistics are some of the spheres where this practice is widely employed. So, what is this discriminant analysis and what makes it useful? So, it is just as the name suggests, it is a way to discriminate or classify the outcome. So, discriminate analysis is, the name itself suggests, it is a way to discriminate or classify the outcome. So, whatever is the result, whatever is the outcome of the research, you try to discriminate them and classify them. So it takes continuous independent variables and develops a relationship of predictive equations. So these equations are used to categorize the dependent variables. Now, in this discriminant analysis, it takes continuous independent variables and develops a relationship or a predictive equation. So, with the help of the continuous independent variables, it will develop into a predictive equation, and these equations are used to categorize the dependent variables. So, with the help of these equations, we will be able to categorize the dependent variables. So, 3 people in 3 different countries are credited with giving birth to discriminant analysis. These people are Fisher in UK, Mahanala Lobis in India, and Hoteling in USA. If you are classifying the data into 2 groups, then it is known as discriminant function analysis or the DFA. If there are more than 2 groups, then it is called multiple discriminant analysis or the canonical varieties analysis. So, if you are classifying the data into 2, then we call it as discriminant function analysis, and if there are more than 2, we call it as the MDA or the multiple discriminant analysis or the canonical varieties analysis. So, this technique is utilized when you already know the output categories and want to come up with a method to successfully classify the data. So, when you already have the result of the research, when you already know what is the outcome, and when you have to classify the outcome, we make use of this technique. Then, say what if you aren't aware of the categories beforehand. In those cases, you would need to perform clustering. So, an example of discriminant analysis is using the performance indicators of machines to predict whether it is in a good or a bad condition. So, this discriminant analysis, it is usually helpful to know whether the machine is in a good condition or a bad condition. So, with the help of the performance of the machine, with the help of the data relating to the performance of the machine, we will be able to indicate whether the machine is in a good condition or a bad condition. So, with this, we come to the end of this session. Hope you have all followed it. Thank you.